In this class, we're going to discuss function of a function. This is another differentiation technique. So how do you differentiate a function whereby it is a function of another function? Functions such as y equals to x squared, x plus 1, everything squared, sine x squared, cos x plus 1, everything squared, exponential, log x squared, log sine 2x. All these are functions of another function. X squared is a function on its own. Sine x squared is the whole another function. X plus 1 is a function. X plus 1, everything squared, is another function. That's why we call it function of another function. If you want to know, like x plus 1 now, if you draw the graph of x plus 1, you're going to have something like this, straight line. But x plus 1 squared, you're going to have a parabola. Got it? So you're going to have a parabola. You can see there are two different functions. So why we call them function of another function is because this, if y equals to x plus 1 everything squared, x plus 1 everything squared is determined by the value of x plus 1 that we have here. So then this technique is about how do you differentiate functions of this form. So the technique says that if y equals f of u such that u also is a function of x, then the technique says that then the y dx will be equals to the y du times the u dx. So something that if you look at this, so it says that first you differentiate y with respect to u, then you differentiate u with respect to x, then you multiply both together. So if you look at what we have here, it's more of like hypothetically. So you can cancel this out and you can see, so you have the y dx back. So an example of this, so differentiate y equals to x plus 1. Let's start with that. Everything squared. Example 1. Example 2. We have x squared plus 3. Everything raised to power 3. So find the y dx. So from what we have here now, we have our first equation is y equals x plus 1 squared. So if y equals to x plus 1 squared, so how do you differentiate this? First, you say let u be equals to x plus 1. You represent, because this is a function on its own. So you represent that function with u. Then u equals to x plus 1. So if u equals to x plus 1, this implies that y equals to what? U squared. Let u equals to x plus 1 implies that y will not be what? U squared. So now you now use the formula. The formula now says the y dx will be equals to the y du times the u dx. First, you find the y du. You differentiate y with respect to u. Then you find the u dx. You differentiate u with respect to x. Now you multiply both of them together. Oh, from what we have here, so our y is equals to u squared. So that implies the y du will be equals to what? Just the way we differentiate x, bring u here, 2 here, 2u raised to power 2 minus 1. And that's equals to what? 2u. That's our y du. So our u equals to what? X plus 1. So then the u dx will be equals to, what is the derivative of x? 1. Plus, what's the derivative of 1? 0. So that's just 1. So this implies that, so from the formula that we have, that the y du, the y dx implies the y dx will be equals to the y du. What's that? The y du. The y du equals to 2u times the u dx. The u dx is what? 1 plus 0, 1 times 1, which is equals to what? 2u. But from here, our u equals to x plus 1. So that means this will be equal to 2 into bracket x plus 1, which is equals to 2x plus 2. So it means the derivative of y equals to x plus 1 squared is equals to what? 2x plus 2. So let's solve the second example. y equals to x squared plus 1, everything raised to power 3. So remember, function of the function is that the y dx will be equals to the y du times the u dx. So then from the equation that we have now, we're going to say let u be equals to what? X squared plus 1. What we have inside here, x squared plus 1. So then this implies that y will now be equals to what? Y equals to u raised to power what? 3. So implies from here now the y dx will be equals to, we differentiate y with respect to u. So differentiate this now, 3 here. So from here now, first we find the y du. So the y du will be equals to 3 u raised to power 3 minus 1. And that is equals to what? 3u squared. 3u squared. So now the u dx will be equals to, where is our u? U equals to x squared plus 1. So differentiate this with respect to x. X squared, you bring 2 here, 2 raised to power x raised to power 2 minus 1, plus the derivative of 1, 1 is a constant, that's 0. So that means we have 2 raised to power 2 minus 1, 1, 2 raised to power x. So that means the y du is equals to 3u raised to power 3 minus 1, and the u dx is equals to 2x. So from here now, from our formula, the y dx will be equals to the y du times the u dx, and the y du is what? 3u squared times the u dx, and the u dx is what? 2x. So this should be equals to, so 3u squared times 2x, 2 times 3, that's 6u squared x. But don't forget, our u is equals to x squared plus 1. So that means you insert u, 6 into bracket x squared plus 1 into bracket x. So that is equals to 6x into bracket x squared plus 1. So that is 6 times x, 6x. So you cannot use that 6x to open the bracket. From here, that means the y dx will be equals to 6x times the x squared, 6x raised to the power 3, plus 6x times 1, 6x. So you can either leave it like that or leave it like this. So that is the derivative of that. So by tomorrow, we'll continue on solving more examples of chain rule. I'll see you in the class tomorrow.